Good morning. Welcome back to my tutorial. We are on the forces uh, with the method of a triangle rule. So, for example, you have this exam problem. Two forces P and Q are applied as shown from point A, which is a hook support, and then this one is 15, and this Q is 25. We are asked to determine trigonometrically the magnitude and the value of the resultant and the direction of the angle using the triangular rule. So we can start here from A. So let's say at A of 30 degrees, meaning from here going here is 30 degrees. Okay, and that is equivalent to 25. So it's 25. Let's say uh, graphically we can count 25. Let's say 5, 10, 15, 20, somewhere 25. And then you have your 15. If I'm going to draw a x and y axis, 15 is going here, just quite little small. So you have 15, maybe 1, 5, 10, 15. So from here we can connect those lines. This becomes our resultant with the use of triangle. This is R, and then this one is our Q, which is 25, and then this one is our P, which is 15. What is this angle? Okay, we can identify from here. Okay, this one is equivalent to 30, which is exactly the same as this. Going here is also 30. So this is also 30. Okay, and then in other words, if that is 30, this is also 30. Okay, and then this one is from our drawing, this is 15. Okay, that's 15 degrees. 15 degrees. So what is this angle? Let us say this is theta, of course, or alpha. Alpha is just equal to the total angle is 180 degrees. It is just like this already. Okay, if we are going to blow or get this, okay, point. So meaning this is 30 and this is 15. This is alpha. The total angle is equal to 180. So alpha is just, or should we say alpha, okay, plus 30 plus 15 is equal to 180. Therefore, alpha could be equal to 180 minus this one. 30 and 15 is 45. From positive, we can make it negative 45. So, alpha is equal to 135. Okay. So, once you have this alpha, then we can compute R by cosine law. R squared, this side is 25 squared, plus this side, which is 15 squared. Okay, and then minus 2 times 25, this one, and then 15, and then cosine of this angle alpha, which is 135. If you use your calculator, you can calculate R is equal to 37.12. Okay, so from the triangle we can also get, okay, now we can get how much is this angle for us to get this, what is this, direction. So for example, this is theta. I'll just write theta. Or let's say I should put here x. This one is theta. Theta is the angle of our direction. So we have sine of x, this one, and the opposite side is 15. I just make here the triangle. It's easy for us to, okay. This is x. This one is 135. The alpha. This is 15. And this is 25. This is your resultant, okay? So sine of x is to 15 is equals to, we can use the resultant r, which we already calculated, 37.12, and then all over, no, angle first, sine of 135, okay, all over 37.12. Therefore we can compute here x equals to 16.6. Now we need this theta, right? The direction from this vertical axis or y-axis going to the resultant. So we know that theta plus x is just equal to 30 degrees. Theta plus x is just equal to 30 degrees. This is 30 degrees, okay? Okay, you have theta plus x equals to this 30 degrees. So you can say theta is just equal to 30 minus x, which is 16.6. We calculated already here. Okay, so theta is equal to 76 point, no, okay, what's the value? 30, it's 20, oh no, 30 minus 16.6. You will use your calculator. It is 13.4 degrees. It's 13.4 degrees. That is coming from, if it is coming from the vertical, okay? But if it is coming from the horizontal, anyway, there's no statement here if it's vertical or horizontal, okay? 13.4 degrees. Now let us have this another problem. Another problem is similar, but here you have to take note. Say this problem, you have trigonometry. You are going to use trigonometry, and then p here is equal to 600. We're required to determine the angle. This one, it's very clear. And then what? What else? Required alpha. If the resultant of the two forces applied is to be vertical, take note that it is already clear that the resultant is going to be vertical. In other words, if I'm going to draw a line, it should be vertical here is the resultant according to the problem, okay? Now if you are going to start with this 900, let's see here, going 900 is going here, it's 900, the angle is alpha, and then take note that p is going there, and between p and 900, this is 900, right? This is p, this is also, this line 900 is going there. So 45 degrees is between p, okay, here, p and the 900 is 45 degrees. Okay, if that is 45 degrees, what is this angle? The total is 180. For example, this is theta. Theta should be 180 minus 45 degrees, or you have 135 degrees for this theta. Now the question is to compute for resultant. So r by cosine law, we can compute r squared is equal to, we can use first This line it's P, which is equal to 600. 600 squared plus this side is 900 squared. Okay, let me just clear this triangle. Okay, what else? Minus 2 times 600 and then this 900 cosine of this theta, which is 135 degrees. R now becomes, using your calculator, you have 1390.57. Now, if our concern is to compute for the angle, this alpha, so we just need, okay, this inclusive angle between R and 900. Let's say this is X, okay? We can use this with the sine rule. You can have sine X all over 600 P. This is 600, okay? And then we can use R, 1390.57 over this angle. Ano? Sine first. Sine of 135. This is theta, which we already calculated here. And then R, which is 1390.57. So therefore, X here could be calculated 17.76 degrees. Now, alpha, what is alpha? Take note that this is 90 degrees, meaning 90 degrees is just equal to X and alpha. And if we have already X, we can compute alpha, which is just 90 minus 17.76 degrees. In other words, alpha is equal to 72.24. Okay, that's all. Thank you, and follow and share this video.